Right, okay, we're going to start if everybody's ready.
Okay.
So morning everyone, and welcome to our webinar about on-site nitrogen generation for breweries. Thank you so much for joining us today. My name's Georgia, and I've also got Olivia next to me as well. You've probably heard from us a few times, letting you know about the webinar. And so our key speakers today on the webinar are Alan and Tony, experts in compressed air nitrogen specifically for breweries. So if you can today, please stay on for the full webinar. We've got some really great insights today, and we should be all wrapped up in about half an hour, so it won't be too long. And there will be a live Q&A as well at the end, so feel free to pop your questions in the chat at any point, and we'll come to those at the end. And I think that's everything from me for now. If you want to take it from here, Tony.
Good morning, everyone, and welcome to this webinar for nitrogen generation for brewery applications. Delighted you can join us today. So just what we'd like to do is just run through some introductions and some key topics I think might be of relevance to you. Nitrogen physical properties, brewery applications overview, commentary about the gas company current situation in terms of N2 and CO2 supplies, market conditions that affect many brewery applications, common concerns. We'll be talking and unpacking a little bit about the technology behind the Parker NitroSource nitrogen generation systems used for brewery applications and the advantages that flow from that. Product compliance, there's some information I'd like to share with you on a case study. We'll summarize that for you, and then we'll dive into any questions that arise from that and frequently asked questions, and we'll do a close as Georgia outlines within the next sort of 45 minutes or so. So just give everyone the opportunity for questions and a close to the session. So introductions. Alan, I'm delighted joins us today from Director. I obviously work for Parker. So good morning, Alan.
Yeah, morning, Tony. Good morning, everybody. Yeah, just a very few words about Direct Air. As a business, we've been 30 years supplying compressed air and associated services to engineering companies throughout the UK. We're a key partner with Parker for their air treatment and nitrogen generation equipment. We operate from our central offices here in Coventry, with branches in Cheltenham and the southwest, and we can support businesses throughout the UK on their compressed air and nitrogen needs. So yeah, over to you, Tony.
Thanks, Alan. And from Parker, I'm delighted to join you. I work for the Parker Sales Company. Parker Hannafin is a Fortune 250 global manufacturing organization headquartered in Cleveland, USA. All of the products I'll be talking about today are manufactured and designed here at our Gateshead manufacturing site in the UK. And as well as manufacturing, we offer a fantastic Parker training academy for all of the master distribution partners that frequently send engineers for their factory training that support these products. Manufacturing to international standards, ISO 9001 and 14001 for environmental protections, and critically, a third-party independent testing from many of the products I'll be talking about today. So in terms of nitrogen, it's a really important gas for brewery applications. It's colorless, it's odorless, it's a tasteless gas, making up 78% of the Earth's atmosphere. Its inert properties and obviously natural abundance make it a highly popular choice for brewing applications for many of the brewing processes. Main purpose really is to reduce oxidation. Nitrogen is used to prevent the contact of the ingredients with air. Air obviously contains the oxygen, which causes oxidation, ultimately impacts the quality and shelf life of the finished product. So beer is obviously sensitive to that, so it's quickly oxidized when exposed to air. So nitrogen protects that product, prevents oxidation, ensuring product quality. Just an overview for you on some common brewery applications. I know that there are many, many more than that, but in the time allotted, I just thought it'd be relevant to share some of the key ones with you. Blanketing, which maintains a positive pressure in sealed tanks. preventing air ingress during volume changes, facilitates product transfer from one tank to another. A really important one that quite a few brewers have shared this with me is clean in place. So unlike CO2, nitrogen will not react with caustic solution when you're running perhaps a periodic clean down. So it will maintain those cleansing properties and allows the reuse of the solution, eliminates risk of tank collapse as well. So there's no loss of gas in that process when nitrogen is used. Packaging, an important aspect of the process with purging of kegs, cans and bottles with nitrogen helps reduce the possibility of oxygen pickup and extends product shelf life. In certain applications where beers and stouts and you're looking for that sort of smooth mouth feel, then a process called nitrogenation is a very relevant application for nitrogen, which ensures that sort of smooth mouth feel and the dense persistent head of foam you're looking for. So the smaller nitrogen bubbles cascade through the beer and give you that long-lasting head and lighter feel in the mouth for those products. So just a summarization really for you on some of the key ones we worked with. So traditional gas company supplies, I think many of you will have seen sort of versions of these formats before, whether it be liquid nitrogen, liquid CO2, and cylinder packs. So, very common ways of getting those gases to the various processes used in your facilities. Current market conditions, and we're very conscious that this will vary from site to site, even on the same sort of locality, really. And in one industrial site, we're conscious that everyone's potentially paying different rates. But some typical gas costs here in the UK, this was during the May, I did a quick summation on nitrogen, typically it's up to £438 per metric ton. CO2 is higher than that, at predominantly around 750. We're conscious, but per metric ton, we're conscious that in certain areas it may be higher or a little lower, but that's a medium price. And the multi-cylinder packs, this is obviously when you're using the high pressure bottles in a pallet form. That's the most expensive format, typically on certain websites at this point in time. That's hovering at 769 a pack. And of course, in addition to all of those, there's the predominant rental charges, delivery, and environmental levies. So traditional gas company supply, and these are some of the very common concerns that we've sort of noted over the years from various breweries, that obviously the high gas cost, there's no control, of course, over that. So that will be completely out of the, as I say, the control of the brewery, those prevailing prices. The refill will interrupt the process, of course, when the tankers turn up, taking valuable space. It will increase site traffic, and that's again a common theme that can cause disruption and concern, particularly around health and safety as well. That if you're managing a high pressure packs, that has to be thought through very carefully. Of course, increased site traffic is very much associated with health and safety and potential near misses as well. The process of producing those gases at the gas company supplies has a very predominant high CO2 footprint due to the high energy requirements to produce that as a liquid. There's always the risk of running out between deliveries as well. And as you've seen, we've all seen in recent years, the availability of CO2 has become very vulnerable. And most of that, in terms of the bulk liquids, can often be tied to quite restrictive contracts. So the solution from Parker, what we're offering for those applications is a low-cost compressed air to nitrogen generation system. It will operate from a standard air compressor. And what we're producing is high purity food grade gas on demand. The generators have touchscreen control and some of the standard features for our NitroSource Plus. As I say, these are manufactured at our Gateshead facility. Energy savings technology, which will naturally modulate the amount of compressed air that they need, so it effectively matches downstream demand. So that's a meaningful contribution to energy savings and reduction of CO2 footprint. Auto standby, so clearly if there's no gas demand, the generators will detect that and go into standby. A gas quality control pack is automatically included. That will include oxygen monitoring, of course. So we constantly monitor the purity of the gas we generate. It's modular design. So that means that from a single bank, it becomes fully scalable to multiple banks if for large applications. Food and beverage compliance. So we adhere to our European and international standards, which is commensurate with EIGA, which is the European Industrial Gas Association statute as far as gas purity is concerned. And all the materials of construction are FAD, Article 21 of compatibility. And 1 + 9 years warranty is a standard feature when our products are offered with the Parker pre-treatment package. So just to share with you a typical layout. So here we start with the air compressor, the blue air receiver, and the pre-treatment pack would consist of a desiccant dryer, what we call the oil-free air system, incorporating activated carbon as well. There you see the generator that flows from that with its dedicated buffer vessel, which supports the cyclic operation, and then a storage vessel, followed by the sterile filter as well. So that gives you a complete package and understanding of a typical nitrogen generation system working from a standard factory supply. It can be multi-banked as well, as I mentioned to you. So there's just one example of where we'd have a single compressor with the air receiver, pre-treatment packages, dedicated buffer vessels. In this particular instance, we've got 2 of the nitrous source as a multi-bank dual supply. Some breweries that have already worked with Parker over the years and continue to reap the benefits of nitrogen generation at those particular sites. So happy to share some specific details with you on those as things unfold. So just a summary for you. We're generating food and beverage grade nitrogen on demand in accordance with international standards. It provides a complete control over your gas supply, of course, and savings often exceeding 70%. We're eliminating multi-year contracts with gas suppliers and unexpected price increases. And we'll deliver constant flow and pressure 24 hours a day, 7 days a week. Operating from a standard air compressor, fully automatic operation and control, sustainable long life technology, energy efficiency, obviously reduces carbon footprint, and eliminate site traffic and safety concerns over cryogenic movements onto site. So some of the key benefits there for you in terms of the product we're offering. So what is the nitrogen generator? So what we'll do now is just unpack a little bit about the technology to share that with you. So Parker's nitrogen gas generators are designed to employ a method of nitrogen production called pressure swing adsorption. So it's a way that we cycle the generators. You'll see there that they consist of 2 sets of parallel chambers filled with a material called carbon molecular sieve. So to the untrained eye, it just looks like standard granular carbon. It's actually heat-treated peach stones, which are carefully graded and packed in nitrogen for storage purposes, but it does have the unique capability of preferentially absorbing oxygen. The oxygen contained within the compressed air whilst under pressure due to the differing molecular size of the oxygen, nitrogen and argon. So this allows the nitrogen, argon and other trace inert gases to pass through the generator and out to the customer's process. So just really an insight into the technology there, that the pore size of the carbon molecular sieve is such that it adheres or allows the oxygen to adhere into its structure where the larger molecules of nitrogen pass through to the process. We pack the chambers very, very tightly and we avoid the shot you see there was a loose filled bed. So that snowstorm filled bed ensures that we have maximum packing density to prevent the sieve bed moving and leaving leaving potential leakage paths. So it's really important that once compressed air goes onto the generator beds, there is 0 bed movement, and that's really important to prevent any issues in terms of inconsistency, in terms of performance and bed quality. So the bed in that particular form is subject to zero movement, and there are no leakage paths through the compressed air to fine. So all of the CMS is effectively utilized. So this gives a very stable performance with maximum efficiency whilst reducing the overall amount of CMS required. So it does enable us to reduce the overall size of the generator, which is always an important when we're looking for minimum footprint required to accommodate the system. Just an insight into the flow capabilities from the models that we have available from the NitroSource Plus. We have the NSP 020 starting at 23.2 cubic meters per hour. So the largest in the family now, we've added the 110 and the 120 at the bottom you see there. So from a single generator, we can generate 137 cubic meters, or just over 137 cubic meters per hour. And this is based on a 7-bar inlet pressure. I should point out to you that the generators will work at a variety of pressures, the minimum being 5 bar, the maximum being 13 bar. So we use the 7 bar just as a median line to give you an indication for this purpose as to the flow capabilities. And of course, beyond that, as I mentioned earlier, these can be multi-banked for large flow applications beyond that of a single generator. Third-party compliance. So I mentioned to you the EU statute for food-grade nitrogen, and these are independently tested so that that when the generators go into service, all of that document pack, I call it a full compliance pack, is provided as part of that supply scope. So that will be the third-party independent test, factory test certification, engineers commissioning report, and ongoing maintenance reports as well. So all of that is kept as a documentary evidence that the system is working to the optimum. Just to share with you a case study in terms of a UK application. So typically a site will contact us and engage with us in that process. We would always clearly outline the project objectives, and in this particular example, end the dependency on bulk liquid nitrogen, reduce CO2 usage as well, and part of that would always be undertaking a site survey, assessing quantified benefits of Parker on-site N2 generation. This particular one came about through the Brewing Engineers Association, so they have a frequent technology day. And that was an opportunity for us to engage with a number of brewers at that particular event, and resulting in this conclusion. So the case study applications include the purging of bright beer vessels, kegging lines, deaerated liquor, nitrogenation, product transfer, and in the near future they'll be moving to tanker offloads as well using our system. So the result, the solution provided was 3 banks of the Parker NitroSource comprising of 2 of the modules. That delivers 84 cubic meters per hour of generation capacity. That's broadly equivalent to about 1 metric ton of bulk liquid. The nitrogenation and deaerated liquor that are part of their process, there's a separate line specifically for that where we set the generator at an ultra high purity level at a low flow, specifically for those applications. Something in the order of about 5 grams of nitrogen per litre was the ratio to work with on that particular requirement. So the result, as you see there on the picture, removal of the bulk tank is in its entirety and the evaporator. And in so doing, we maintain the product quality for the customer, which is vitally important. Remove the tank, reduce the bulk CO2 usage by over 35%. And on current trend, a payback on capital in less than 36 months, reduced CO2 well over 60%. Reducing the site traffic was really important to them. And the control over supply is critically important too. So let's look at that as a summary. So we've maintained the product quality, reducing costs, take control, improve sustainability for the site. We've reduced the site traffic. We've addressed health and safety concerns as well. Obviously, you've previously had a very high volume storage of potentially asphyxiant gas and cryogenic liquid. So that's now addressed. And what we'll do is engage with what we'll do to encourage you is to engage with the director sales team, sign up for a free survey. We're here to help. So coming up, Director will be exhibiting at the Brewers Congress on the 30th September to the 1st of October in London. So we look forward to seeing you there. And moving forward, I just want to thank you for your participation. And now we're just opening up to some questions.
Thanks, Tony. That was great. We've got a couple of questions, probably mainly aimed at yourself, Tony.
Right, okay.
So first one is, where is the equipment manufactured and what is the lead time for that as well?
Okay, so as I mentioned, the equipment is manufactured here in the UK at our Gateshead facility. So that's a facility in the UK that was established well over 40 years ago. So all of the R&D technology and the manufacturing is controlled there. And typically the lead time on these products is 6 weeks from Parker, 6 working weeks.
Lovely. Hope that's answered that question. Next one is, do we need an oil-free compressor?
It's a very, very common question. So the answer to that question is no, you don't. A standard factory air compressor, if the brewery already has spare compressed air capacity from a standard oil lubricated machine, that's absolutely fine. Equally, if that's not the case, then as you saw in those shots within the presentation, the generator system can be incorporated with a dedicated air compressor from Direct Air, which should be a standard machine. Just to remind you, in the shots that we saw earlier, the compressed air is pre-treated by the Parker oil-free air system. So that ensures the air quality that is fed to the nitrogen generator is already of a very, very high standard requirement for the generator to perform as we would wish.
Lovely. And can this equipment be installed outside?
No, it can't. So the answer to that question is that it needs to be installed either in a well-ventilated plant room or weatherproof enclosure. It's really important that we protect it from the elements.
Makes sense. And what is the life of a CMS and how much does it cost to replace?
Good question. Yeah, great question. So the CMS, which is the acronym we use for carbon molecular sieve, we saw the internal shot of that earlier. So the good news is that the CMS is there for the lifetime of the generator. So we put that as a minimum of 10 years. And consequently, we don't actually class that as a consumable part because with the right protection from Parker, i.e. the pre-treatment package to ensure that the air quality is of optimum standard, then the CMS will be there for the lifetime of the generator. Employing the snowstorm filling technique as well, it ensures that the CMS is kept in optimum condition throughout the lifetime of the unit.
Great, thank you. And also, what are the materials of construction?
So the materials of construction is aluminium extrusion at the heart of the generator. These are treated as well to prevent any corrosion from occurring. And we connect them together with top and bottom manifolds using high tensile stainless steel Lloyd's approved bolts.
Lovely. Last one now. This is a health and safety question. So, will the nitrogen generation package create a health and safety risk due to high or low oxygen in the plant room?
Great question. So, as you saw earlier on, the generator cycles from one side to the next. What we, as we outlined, pressure swing absorption. The pressure swing absorption means that the oxygen is stripped from the bed during the cyclic operation. And importantly, as well as stripping the oxygen from the bed as we exhaust down from pressure to zero pressure, we also use a small amount of processed nitrogen as well. So the net effect of that is that when the two gases mix together in the plant room, effectively they will dissipate very quickly, and the oxygen content or the oxygen in the environment within the plant room can typically be between 19.5 to 23.5, well within health and safety guidelines. On certain occasions, an oxygen analyzer can be installed in the plant room as well for added peace of mind. So that would just ensure that if there was, for whatever reason, a high or low oxygen occurrence, that could be captured, and a visual and audible alarm could be connected to the system on the building periphery, just ensuring that it's safe to enter. But that's pretty unusual. Generally speaking, most of our systems operate in a well-ventilated plant room without the need for additional monitoring.
Great, that's lovely. Sorry, just one more quick one, Tony.
Yes.
What is the approximate timescale for return on investment for the equipment?
So the approximate timescale in our experience here is 12 to 36 months, depending on the system scope and what's involved. Certain applications will enable us to utilize the existing air capacity from site, so that will obviously reduce the amount of the payback period. It will be extended slightly if we need to incorporate additional costs to accommodate a compressor and other peripheral requirements in terms of a weatherproof enclosure and so on. So it will vary, but very typically 12 to 36 months.
Great, that's perfect. Thank you. And if there's no more questions, I think that's all.
Okay.
So we will be sending out the recording as well afterwards. So if anybody missed part of this, you can catch up on that. It'll also include this Q&A as well, which will send out a bit more about the questions and answers that we had.
Brilliant.
And I think that's everything. Thank you.
And any other final questions from any of the participants today? Very happy to hear them. Any closing thoughts?
No, well, I mean, I think that was excellent, Tony.
Thank you.
Yeah, very, very good presentation, and I think it will help a lot of people. And we'll be more than prepared to visit any site to assist in their nitrogen requirements.
Lovely.
Excellent. Thank you, guys. Much appreciated.
Thanks,
Thank you very
everyone.
much. Thank you.
Bye.
Cheers.
Bye.